Hello, I'm Nicholas Blanco, and I'll be solving question 2 from exam 1. This is for Dr. Jafar, and going over this, question number 2 is compute the volume of the solid formed by revolving the region around it bounded by the graphs y equals x squared plus 1 and y equals 0, y equals 0 as well, that was a typo, and x equals 1. So to begin, we'll start by graphing these graphs, and we'll start by graphing x squared plus 1. So since it's x squared, that is a parabola, and it will be moved 1 unit up. So it will be right here, 1 unit, and then x equaling 1 would be right here. That would be a straight line, and y equaling 0 just implies that it is bounded by the y-axis as well, and we will be revolving it around the y-axis. So I'll just make a note of that. So to begin, we'll also note which lines are which. This is our x squared plus 1, and this will be our x equals 1. So we'll start by shading the region that we will be revolving, and we will take an approximation rectangle. This approximation rectangle will be rotated around the y-axis, so our entire thing would be something kind of like this. So in order to solve for this problem, it'd be easier to use cylindrical shells. That's not how you spell shells. Alright, so in order to use solve by the method of cylindrical shells, we would have to take an integral of the upper function and the lower function, which we would do so by saying, well, in this case, it would actually not be between the upper and lower. Since we're using cylindrical shells, we can just take the upper function, and then this x equaling 1 would act as a limit. So it'd be the integral defined between 1 and 0, and our radius would be x squared plus 1 for this problem. So it'd be x squared plus 1 multiplied by x. Also, the entire integral will multiply by 2 pi. And it is defined between limits of 1 and 0, as we previously discussed, because it is going between these 2 points. So in order to solve this, we'll start by distributing the x to the radius, and that will give us x cubed plus x, defined within the limit of 1 minus 0 multiplied by 2 pi. Can't forget our friend dx. We can solve this integral, and it's a simple linear linear integral. So it'd be x over 4 divided by 4 plus x squared, not cubed, divided by 2. And our limit was 1 to 0. The entire thing would be multiplied by 2 pi. Can't forget our friend 2 pi. So we'll plug in that 1, and that'll give us 1 plus 2 minus 0 divided by 4 is still 0, and 0 divided by 2 is still 0, so it will be 0. So solving, we will add, this 0 can be disregarded, and then we'll add these two, and that'll give us 3 over 4 that we will multiply by 2 over pi. That will give us 6 pi over 4, and 6 pi over 4, doing some elementary school math, we can solve this as 3 over 2 pi, giving us the area, or the volume of this rotated curve.